The last possible issue with polynomial division that we're going to discuss is one that makes polynomial division both better and worse than division with numbers. When we divide numbers, sometimes we have to do some sort of funky borrowing or carrying. Maybe the first digit of our divisor doesn't go evenly into the first digit of our dividend, or maybe when we multiply there's some carrying that makes our number too big. That never happens with polynomials. But what does happen is if the first term of our dividend doesn't go evenly into the first term of our divisor, we might get a fraction. And that's fine. Polynomials can have fractional coefficients in them. But it makes our lives a little bit more complicated. Let's see how we deal with that. So in this example, I'm going to show you what I'm thinking again, because I'm thinking something a little bit different. We're going to start exactly the same way we have so far. We're going to divide the first term of our divisor into the first term of our dividend. So we'll take 6x to the third divided by 2x, and that'll give us 3x squared. No problem, no fractions so far. We multiply our 3x squared times 2x plus 6, and that'll give us 6x to the third plus 18x squared. We subtract. 6x to the third minus 6x to the third is 0. 13x squared minus 18x squared is negative 5x squared. Finally, we bring down the next term, negative 12x. Okay, our next step is to take our first term here, divided by our first term here. Negative 5x squared divided by positive 2x. When we take negative 5 divided by 2, we get a fraction. It's going to be negative 5 halves. X squared divided by x, well, that'll be an x. So our next term is negative 5 halves x. I'm writing it this way instead of this way in order to make it look like a polynomial. Negative 5 halves x looks like a number times x, whereas negative 5x over 2 looks like a rational expression. Okay, so that's fine. That's going to make my multiplying a little bit more complicated, just because I have to do fraction multiplication. Negative 5 halves x times 2x is negative 5x squared. Negative 5 halves x times positive 6. If I like, I can do that fraction arithmetic on the calculator. Negative 5 halves times 6 is negative 15. So that'll give me a negative 15x. Negative 5x squared minus 15x. We subtract. Negative 5x squared minus negative 5x squared is 0. Negative 12 minus negative 15 is positive 3. So I have a positive 3x. Bring down my last term, which is 15. And now we're on to another divide step. Again, first term divided by first term. We have 3x divided by 2x, which is 3 halves. So the last term in our quotient is going to be plus 3/2. When we multiply, we'll be taking 3/2 times 2x plus 6. 3/2 times 2x is 3. 3/2 times 6 is 9. And again, you can do that multiplication on the calculator if you'd like. We subtract. 3x minus 3x is just 0. 15 minus 6 is 9. So we have a remainder of 9. What we write is plus 9 over our divisor, 2x plus 6. Now, it turned out that when we did our multiplication, we didn't end up having to deal with any fractions here. That wouldn't necessarily have to be the case in every problem. We might end up having to do addition and subtraction with fractions as well. And if that happens, it's just fine.